what I expect most from recycler side, what we ask, and from investor side also, is stability in legislation. And that is probably the main barrier today why there is not so much recycling capacity in Europe. It is because the legislation, chemical legislation, changes all the time.
For the future, what we are facing is the forbidden molecules for the POPs or which of high concern substances, because the recyclers are victims of the past. It means that the authorities give license to produce toxic substances, and now we are facing a lot of problem to separate those very complicated molecules, those additives that they put in the plastics.
One of the biggest issues, if we look back in the past, is that we see one flame retardant being restricted. It's being replaced by another one, but chemically is similar. So 5 to 10 years later, also that one is being restricted, and we come with a replacement, and so on and so on. So it's kind of a never-ending story of replacements that are being restricted. In the sector, we start talking about regrettable substitution, and that is really that is one thing. What I am really afraid of, what you see today, is that there is an evolution towards, on the one hand, polymeric flame retardants, because it is bound to the polymer, that it is less likely to degrade into a toxic compound. But a polymeric flame retardant, for instance, cannot be removed by dissolution. So if by any chance that polymeric flame retardant would become restricted in 10, 15 years, then dissolution will not work anymore. That is one. The second evolution that we see is towards phosphate-based flame retardants, and that's an evolution that's already going on for quite a while. There is a big difference in recycling. A brominated flame retardant, because bromine is a heavy element, it makes the plastic more heavy, and we can quite simply separate them by density separation. A phosphate-based flame retardant, phosphorus is not as heavy as bromine, so the density difference is less important than with a brominated flame retardant, which as a consequence has that for us it is practically impossible to make a separation between the non-flame retardant plastic and the phosphate-based flame retardant. Should that happen, that these phosphate-based flame retardant become restricted, and it is already the case for 2 of them, then we might face a huge technological issue, because today there is no technology available, and there is no technology under development which will be able to do that separation. To summarize this in a design for recycling mindset, how can you solve this? Well, if you start designing a plastic and you design a plastic with a flame retardant, well, then design it so that the density of that plastic is significantly different from a non-flame retardant plastic. So that means that with current technology, it will always be possible to separate them, whatever happens. And set aside of being restricted or not restricted, there is also another aspect, and then looking more towards design from recycling. If you want to source a recycled plastic for use in whatever application, it is the same as with a virgin plastic today. You want to know exactly what is in. So as a producer will never be happy with a recycled plastic where the recycler says, there is some flame retardant in there, phosphate-based, it's not restricted, but I don't know how much. And that's not acceptable either. So also from that aspect, it would be good to design a flame retardant plastic so that it can always be separated from a non-flame retardant plastic. Because the choices they make, they immediately impact the recycling in 5 to 10 years.